Hello, everyone. Thank you for joining us today. I'm Yasmina Greco. I'm with O'Reilly Media, and I will be your host for today's webcast. We would like to begin today's program by saying a big thank you to Aerospike for sponsoring our event and let you all know Aerospike is a high-performance NoSQL database that is unmatched in offering extreme speed at scale with high availability and remarkable economy for companies with real-time mission-critical applications. Customers choose Aerospike for its consistently high throughput, low latency, seamless scale-out, and lower TCO advantages. Thank you again, Aerospike. Joining us today from Aerospike is Peter Milne, and he is going to tell you why you shouldn't be frightened by moving to NoSQL. Peter is a senior engineer at Aerospike. Prior to Aerospike, Peter was co-founder and chief technology officer at IT Iterative Consulting, a consultancy company providing software modernization to clients worldwide. While at IT Iterative, Peter was also the technical director of a project to develop a consumer lending application at St. George Bank, a national bank in Australia. We are very excited to have Peter with us today to present this webcast for you all. As we get the event started, I'd like to go over a little housekeeping to help you get the most out of today's event. First, you'll want to open your group chat widget if you haven't already done so. This is where we can interact with each other during the event and where you can submit your questions for Peter. We find that our audiences usually have a lot of good knowledge to share, so we encourage you all to chat freely during the event. However, if you have questions for Peter, please preface them with a capital letter Q. That way, we'll know they're for him and we can make sure we see it for Q&A. You can also open, move, and resize any of the other widgets. If you would like to tweet from the Twitter widget today, you might need to give it permission to access your account. The Twitter widget will automatically append the event's hashtag to your tweet so you don't have to. And today, folks, our hashtag is Strata Hadoop, all one word. If you should have any trouble with the webcast, please take a look at your help widget. If you continue to have trouble, just post it in the group chat and one of our staff will help you right away. For choppy audio or stalled visuals, please try refreshing your window. And remember, the best thing you can do for a good audio stream is close any apps that could interfere. People always ask, so we'd like you to know we are recording today's webcast, and we will have the recording ready usually within 48 hours. And folks, at this time, it is my pleasure to turn the program over to Peter. Hello, Peter.
How you doing?
Very good. We're happy that you're with us today to present the webcast.
Thank you very much. So everyone, thank you for taking the time to listen to me. The title is Don't Be Frightened of Moving to NoSQL. And the implications are that you all have some kind of background in computer science or developing applications or managing developers or managing production. And you've heard about this NoSQL stuff and there is some value to your organization in using it. First up, let me talk about some philosophy. Wisdom versus guessing. Einstein is attributed to saying that insanity is doing the same thing over and over again, expecting different results. And a less-known fellow by the name of Charles Duell from the US Patent Office in 1899 said, "Everything that can be invented has been invented." So those two philosophies are diametrically opposed to each other. And the reason I mention them here is that if you're going to do something new, something that hasn't been done before, in your experience, in your software organization, in your business organization, you may have to do something differently to get success. Let me go back and do a little bit of history on relational databases. Why do we love them? All of you, when you went to university to learn how to do things with computers, in the first or second semester was introduced to relational database systems. They are the Bible. They are the way. They are the truth. They are the light in which we store data. They give us a level of comfort, things like reliability and ACID compliance and the wonderful power of two-phase commit and the strength and rigor of a schema. And this is what we've all done. This is what we've all learned since we first started in computing, was that when we wanted to store data, we would start to think, how can we take the data we have in our application and jam it down into rows and columns and tables? Ted Codd was one of the founders in the whole notion of relational technology by proving his ideas and thoughts using relational calculus. He was able to come up with something that has survived the test of time. You do remember relational calculus. It was probably taught in the middle 3 or 4 lessons in your semester on relational databases. Those are the classes that we all thought we'd like to do something else in and we were having trouble staying awake for. But it proved the theory and passed the test of time. Everybody has used a relational database. But different problems need different solutions. So in the old world, the difference between online transaction processing and online analytic processing, the requirements are very different. What is the problem you're trying to solve? And what is the solution that you want to have? So in the modern world today, as the amount of knowledge and information expands geometrically, we have new problems to solve. We might have a session management or a fast transaction problem, or a cache requirement, or some kind of aggregation or analytic ad hoc scans of information. When these things get to a certain scale, they can't be done with the traditional technology of relational database. So why do we bother going to something new when we've got something that works? You've heard the expression, if it's not broken, don't fix it. Well, in our situation here, we are now expanding into a new century where information is broad, deep, and rich, to the point where information seems like noise, and we have to divine the signal out of that noise. So we have new problems of scale, new problems of performance, new problems of complexity, and new problems of developer productivity. So there are now a bunch of new data storage technologies which fall under the banner of NoSQL. Of course, Aerospike is the best because I work for Aerospike. Aerospike will solve global warming and Middle East peace. But there are other technologies, things like Redis and Cassandra and HBase and Couchbase and MongoDB, React, Neo4j, Tokyo Tyrant. All of these technologies solve a certain kind of problem. In fact, it reminds me of the time when relational technology was first emerging. For those of you who weren't around before we had relational databases, we used to store things in index files. So what would you get and what are you prepared to sacrifice by going to NoSQL? So relational databases give us consistency. They give us multi-record transactions. They allow us to have some wickedly complex queries, sometimes crazily and stupid queries. We have a schema, which is like your mother, which makes you obey the rules when you're in the house. There's a lot of tradition associated with relational databases, of some ritual associated with them, and some regulation. And I'll talk a little bit more about these points later on. With NoSQL, we might want to get some speed that we can't get out of our relational database. We might want to scale it. We might want to distribute it so that we have parallel processing NoSQL means not only SQL, so we probably won't have a schema, or a schema that's very easy to update. NoSQL is the latest fashion, it's nouveau. There is no regulation. You can do what you like. You have freedom. But with freedom comes responsibility. So a relational database allows you to do everything. You can solve every technical complex problem with a relational database. There's lots of tools to help you, and everybody knows it. NoSQL is about focusing on a specific need, a particular need, where you model your data for a specific use case rather than in a general sense. And you are usually looking for something like increased speed and increased scale. So a relational database is the Swiss Army knife. It's got every tool that you want to do, and if you carry it in your pocket, you can solve every problem. But if you carry a big Swiss Army knife in your pocket, it's big and heavy, and it bangs against your leg as you walk and demands your attention and is a whole infrastructure in its own self. NoSQL is a specific tool for a specific job that you're going to solve. Probably speed at scale or throughput or something like that. So what is your goals with NoSQL? So I've got some graphics on the screen. I hope you can recognize where they're all from. The first one is usually speed. With NoSQL, you want to solve a problem that's about a latency of about a millisecond or so. You want to do a read or a write or a store and a get in about a millisecond or so. That's one of the reasons you may go to NoSQL. The other one is scale. You have gone from a gigabyte problem to a terabyte problem and perhaps to a petabyte problem. Never before in the history of computing have we had the need to store petabytes of data and to access that sort of scale at speed. The other problem you might be trying to solve is volume. You might have started out with 10,000 transactions a second, reads or writes a second. And now you have a problem that demands that you do 100,000 of them a second. Or perhaps you have a problem that you're trying to solve where you're doing millions of transactions per second. And every second of the day, every day of the week, every week of the year. And the last one is a little esoteric and is kind of a pub discussion. So people will have some passionate opinions on these, is developer productivity and flexibility. To give an anecdote on this, about 5 years ago, I was working on a project in Australia at a large bank in the retirement fund investment section. So in Australia, you can manage your own retirement fund by buying and selling shares, so long as it's done through an authorized vendor, and the bank was an authorized vendor. In their management of relational databases, there were 2 columns in every row. This was the number of times the record had been written, and the second column was the last person who wrote it. Now that's quite a useful technical requirement to have in any kind of optimistic concurrency system or audit system. But the database administrators had given the commandment, declared the proclamation, that the last 2 columns in the table would always be these 2 values. So if you wanted to add a column, you couldn't just simply go add column in SQL. You actually had to copy these other columns to somewhere else, add the new column, and then copy them back. That was their criteria, because they wanted to say select star from table name and have the technical pieces of information be on the right-hand side. So that was a dogmatic approach, and it constrained the productivity and flexibility of developers. Moving those columns around took time. The size of the database said that it might take hours, and then you had to schedule it through a third-party organization to do it. So you get some esoteric advantages in NoSQL by granting flexibility and productivity back in the developer's hands. So I've said what you could gain. The next thing you need to do when you're thinking about NoSQL is, what are you prepared to sacrifice? Are you prepared to sacrifice two-phase commit or an XA-compliant database? Do you need two-phase commit for the problem you're trying to solve? While we all think we do, many problems in computing actually don't need a two-phase commit protocol. Are you prepared to sacrifice joins? Multi-way joins, joins on the same table, stupid joins, joins that join back on themselves 3 times. Joins solve a certain kind of problem, but do you need them for the problem that you want to solve in NoSQL? And the last one, once again, this is the world of philosophy, where we have dogma, where you have the purest data model. You remember that fifth normal form was what we got taught at university as the nirvana, the absolute purest and the best way to have a database. But do you need it to solve your problem? Or is it just a fashion or a commandment? So what are you prepared to sacrifice to get some gains? Let me take a minute and talk about the stereotypical NoSQL databases. This will be at a really, really high level because each of these databases can do lots of things, but they're good in a certain niche. So there's the KeyValue store and the key document store. So Aerospike is a big KeyValue store on steroids. It has some wonderful capabilities. We actually go from a key to a record rather than just a single value. But in the same kind of space is React or Redis or Kyoto Tycoon. Same general technical loose grouping. Alongside of this is the kind of key document stores. Documents are a very fashionable way for you to store data in a semi-structured form nowadays. So if you're familiar with JSON or XML, that's the kind of thing that you refer to as a document. So MongoDB and Couchbase are loosely classified in these spaces. But I'll emphasize again that each of these technologies on the screen have additional capabilities, additional strengths, and additional criteria that you would use when you chose them to use in your production environment. Then we have some column-oriented databases. Things like Cassandra and HBase are particularly brilliant in a column-oriented problem. So you have to decide whether you have a row-oriented problem, essentially a primary key that you're going to access your data with, or a column-oriented problem, which is multiple filters in a where clause, where shoe size is between 8 and 16 and color is black. That's a column-oriented problem. And then we have the unique space of a graph database. So when I was a little boy going to university, we talked about mathematical graphs and we did them, but nobody could quite work out what they were used for. Today, the internet is a big graph, but more closer to home is the notion of social media, where through LinkedIn or through Twitter or through Facebook, we have an individual has a connection to other individuals. So the individual is a node or a vertice in a graph, and the connection is a link or an edge in the graph. So the biggest thing you can do not to be frightened about moving to NoSQL is the way you model your data. The success that you have will be directly proportional to the data model that you have. So I'm going to go over this a little bit for you. The first thing is normalization. Once again, remember when we did our studies in relational technology that we wanted to strive to get to fifth normal form. What fifth normal form gives you, or normalization gives you, is the smallest database to store your data. It also gives you the slowest database. So why was it important for us to have a small database? Well, in the 1980s, 300 gigabytes of disk storage was a machine about the size of a washing machine. The disk storage itself was 20 aluminium platters coated with iron oxide, and they were arranged in a disk pack on a spindle. The platters were like gramophone records or old vinyl records, and they spun around, and heads would fly over the tops of those platters and read and write the data. So the washing machine that you put this in cost around $250,000 to $300,000 in the 1980s. And the disk pack itself was about $25,000. So think about that. That's $250,000 to $300,000 worth of storage, and you got 300 megabytes. Today, we all walk around routinely with flash devices that cost us a few dollars, and they store 8, 16, 32 gigabytes of data, gigabytes of data. So the value of having a fifth normal form database is less in this age because the cost of storage is many times, many orders of magnitude cheaper than it was when the technology was invented. There is a value in normalizing data. I'm not proposing that it should never be normalized, but what I'm saying is that some of the rules that we have learnt don't necessarily apply if we want to have speed or scale or throughput. So let me talk about denormalization. And so it's a nice fancy term, but what it really means is duplication. It means you're going to duplicate data. Instead of having one copy of someone's telephone number in your database, you may have it in 6 or 7 places. And it's okay. Denormalization will give you speed, and it's particularly good for immutable data. If you write the data and you never update it, it doesn't matter if you have 10 copies of it or 10 elements associated with it. It's going to be right and it's going to be there forever. You do need to work out the difference between aggregation and association, or consists of versus related to. So I have 2 graphics to help you out there. Ignore the handsome helicopter pilot for a moment and just look at the helicopter. The helicopter consists of a hull, a tail boom, a tail rotor gearbox, the tail rotor itself, an engine, the main gearbox, a mast, the rotor head, 2 rotor blades, and 2 skids, and 4 seats and some controls. While all of those things are separate components, the helicopter is not a helicopter unless they're all put together. So it consists of all of those things. It's an aggregation of all of those elements. The pilot is related to the helicopter for a short period of time, but the components are there for the life of it. So in your modeling, understand what consists of or aggregation means. Or if you look at the graphic on the right-hand side, you have related to, and there is 2 people who indicate that they're related to each other, that romantic scene, the sunset, and they're holding hands. This is a relationship. Those people aren't consisting of each other. They aren't made of each other. They have a relationship with each other that may last the rest of their life or could last until he does something stupid and she slaps him. So that's the difference. Consists of is they are part of each other, related to, there is a connection there for an indeterminate period of time. This is an important concept to understand when you're going to model your data. So let me talk about aggregation. This is where you're going to embed a data structure inside another data structure. So rather than having a one-to-many relationship between a person and 0 or more telephone numbers and putting them in separate tables, you might have a list or a collection of telephone numbers in the person entity that you're storing, the person record, the person document that you're going to store. Why do you do this? First of all, what you're going to do is that your read and write is going to be fast. Although it's going to be a tad bigger, it's going to be essentially one I/O to the storage, or the least number of I/Os to the storage layer. When you do this, you can get a level of parallelism through your clustering so that people aren't competing for locks, table locks, or page locks, things like that in a database. But what does it cost you? What it costs you is that the updates, if you're going to update a piece of data that's in a few different places, might be a bit more heavy. You might have to think about it a little bit more. But aggregation gives you velocity. Let me talk about joins for a moment. There are two types of joins that we do. Some of them are horrible joins. On a project that I worked on a few years ago, there was the most ridiculous database structure I'd ever seen. It had about 600 tables, and to do any activity, you had to join to at least 3 or 4 tables, and in some cases, you joined back to the same table you were working on. It was the most horrible object-to-relational model that I'd ever seen, and it was absolutely stupid. But it had been in production for 10 years, and everybody was too frightened to fix it. So let me talk about joins. There are 2 ways to implement joins in NoSQL if the NoSQL database doesn't support it directly. The first one, if you're doing frequent joins, then it's time to do something like aggregating the data into a single record. And I'll go.
All right, folks, looks like we lost Peter for just a moment. We'll get him back on the line, so give us just one moment with that. And if you would like, you can access a copy of the slide deck. It is located in your green file folder widget, right there on the bottom of your widget tray. You have access to that for you. We apologize, folks. Just give us one moment to get Peter back on the line for you. And also, for those of you that may have joined just a little bit late, you can send questions and comments at any time. Just open your group chat widget. It's a little brown icon there in your widget tray. Type in your questions, comments, send them in, and we'll take as many as we have time for at the end of the event.
Hi, everybody. I apologize. I live in the third world of Dallas, Texas, and my landline just cut out.
No problem, Peter. Thanks for calling back in. We'll turn the program back to you.
Thank you. So I was talking about joins in your code. It's probably a little joke in there somewhere because I've just rejoined the conference. But frequent joins that you would do, you may as well do it in aggregation using a composite key or an aggregation of some kind. Infrequent joins, do in your application. So let's take the example JSON below. Here we have a user profile, and it relates to a photograph. So there is a unique ID and a first name and a last name. Now, normally in a relational database, we might list the interest in a separate table. But whenever we get the user, we want to discover their interests as well. So here we have aggregated that list of interests and put it in the same record as the user profile. That's the common case. That's the frequent join that we want to do. The infrequent join is occasionally we want to go and look at the photograph of that person. So rather than actually doing that, storing the photograph in the record of the user profile, we have a tenuous link that we can use in the application to do the join. So another technique you can use is composite keys. This is where you store a piece of information or a set of information in a composite key. So let's use a couple of examples here. Here we have a chat example. So we have user 1 is chatting with user 2 on December 25th, 2014. And inside that chat record, pointed to by a composite key, is a list of the things they've said to you. Hi, how's it going? Good, thanks. That is a way to store your data using a composite key. And that's a really simple one. You could imagine how that could be done in a Twitter-like application or anything else that does chat. But let's look at a bank account situation. Here we have the notion of a user and has an account balance of 100 and a timestamp that the last time the account balance was calculated, then a list of transactions that have occurred on the account. So here is a very more complex object. The account balance is valid at a certain time, plus since the account balance was calculated, we have a set of transactions that we can use to do a calculation on the actual balance of the account. Let me go into that in a little bit more detail. Oftentimes in NoSQL, we want to capture a bunch of events that occur associated with an entity. It could be the clickstream a user is doing on a website. It could be the websites people have visited or the search requests they have made. For example, Google keeps all of the things you searched for. As embarrassing, as frightening as that might be, they have a list of them. So in the case of a banking example, I mentioned it before, here we have a user account that has an account balance that's based on a certain time epoch. Since that time epoch, there have been a few transactions. A transaction to deposit $10, a transaction to remove $25, a transaction to deposit $100. I know you all think that your bank does things with XA transactions and two-phase commit when you move money from one account to another or you pay somebody, but that's not true. Banks have a very complex and involved protocol in transferring money from one place to another, from one account to another, even if it's just ledger to ledger. And this technique of capturing user events from a certain epoch in time and then doing a reconciliation at some future time is a very common technique. In a row-oriented NoSQL database, you would put these in a list or a byte array or a set. In a column-oriented database, you would simply add columns. So I've dealt with NoSQL at a reasonably high level. I have some advice that I like to call Uncle Pete's advice. This comes from starting in the IT industry in 1980 and working through all of the craziness that has gone along in the last 35 years. So the first thing that I give you as advice is decide what you want to achieve. Speed and scale are probably the things you want to achieve. NoSQL is part of big data and is usually the operational edge data that you want to use. Know your traffic. Know how many requests are going to come into your service, your app, your website, whatever you're doing, and how many of those, how many reads and writes translate from a single business request. So if you have 10 inbound business requests a second, how many reads and writes to the database does each inbound business request do? The next thing is know your data. Know how big and how wide and how popular and how rich or how bland your data is. Don't guess. Consider also the things that you can sacrifice. Do you need your data to be consistent? And in your mind, you all go, absolutely, it must be consistent. But there are many kinds of data that doesn't need to be consistent. And perhaps you're now stepping into the shallow end of the pool where your consistency may not be as important to you, or immediate consistency may not be as important to you. Do you need transactions? And I mean two-phase commit XA style transactions. Do you need it to get your job done? Although we've used them always in relational databases, in actual fact, possibly only 20 to 25% of the transactions we do actually need to be XA compliant. And the next question is, can you suffer some data loss? This seems kind of a strange question, but perhaps your data is useful for a short period of time, and rather than 1 and 1 adding up to 2, it adding up to 1.9 or to 2.1 is good enough. Those are the symptoms of having data loss. And you'll need to apply a polyglot approach to your persistence. You're never going to take your relational database and throw it away and completely replace it with a NoSQL database. But you are going to take some data out of it and put it into NoSQL. And you'll need to access both of them. And the last thing on this slide is model your data. I've given you a little tickler in the previous slides on how to do that. But know your data, model your data, think about what you're going to do, what reads are going to happen and what writes are going to happen. Now this seems a little bit obvious. I'll mention it specifically. Your application, whatever you do, has some latency. And if you're looking for velocity, if you're looking for speed, the latency of the application will be the sum of the latencies of the devices or the hardware that you're using, plus the sum of the latencies of your own stupidity. This is where you write code that is expedient, or you're in a hurry, or you've cut and pasted it from the internet and haven't really looked at what it does, and you end up with slow running code. It's your fault. And you come back in a year's time and you look at that code and you're so embarrassed at yourself. So minimize your own stupidity. Everybody makes mistakes. Everybody does dumb things. But like the sweet dear lady on the screen, she didn't know that the moon was bigger than an elephant, because from her perspective, the moon was just a tiny little white dot in the sky that if she held up her thumb, it would cover it. So perhaps you need to look at something from a different perspective to understand what the real problem is. The next thing is the right tool for the right job. You can use a hammer to drive in a screw, and it will work to some degree, but it won't be as effective or as strong or as flexible as using a screwdriver. You can use a very sharp knife to shave your face, but you have to be highly skilled and have had a lot of practice, and there are huge risks involved. If you're fixing the wheel of your pickup truck, you can stack it up on rocks because you don't have enough jacks. It will work, but there are risks involved. You have to spend a lot of effort in choosing the rocks and be very careful what you do while you're under that wheel arch. And you can use a saw to cut an apple. It does work, but it's a bit messy and it's a bit of an overkill. So in the space of NoSQL, work out what you need to do and choose the right tool for a job. An anecdote from the past was I was working with a company in Australia who were doing real-time online advertising bidding. And they were in love with a certain technology. They were married to that technology. They were committers to the open source of that technology. They loved it. They absolutely loved it. Unfortunately, it wasn't fast enough for them, and they couldn't break their love affair with it to look for something better. And as a result, they went out of business. So choose the right tool for the right job. Let me talk about load testing. You've got to simulate real load. If you come up with a clever idea and you thought it through, you've only thought through about 80% of it. Simulate real load. And once you've done your simulation, nothing is better than real data. If you can record your current traffic and play it back, if you can use an existing database, play it back. The graphic in the center of the screen in the bottom is the wing of the 787 Dreamliner built by Boeing. And you'll notice that wing is being actually bent up beyond the required flexation of normal flight. The reason Boeing does that is they want to test the wing in a controlled environment beyond what's required of it. Because if the wing breaks on an aircraft in flight, it's a bad day for everybody. So to relate that back to your environment, if you've just done something very clever and you've got it all working and it's running in production and you haven't tested something, you'll be on holiday in the south of France or in Maui or somewhere like that. You'll be sitting there with your significant other, laying in the sun, and your phone will ring, and it's your boss to tell you that the system is down, that you have to interrupt this vacation. And your significant other will give you that look, and you know what that look is. You tell them that you have to go back and fix the problem. So nothing is better than real data. Finally, my final words of my old man sage-like advice is that a well-designed and built application should deliver the correct result. If it does not, then you haven't done your job correctly. At a large bank in Australia, I was asked to come in and look at a performance problem with a colleague of mine. And while we were looking at the performance problem, which was the craziest thing in the world, we noticed that their fantastic, purist, nirvanic, object-oriented framework had three methods in it. One was begin transaction, one was commit transaction, and one was rollback transaction. And then in the begin transaction, the code began a transaction. In the commit transaction method, it committed the transaction. And in the rollback transaction method, it also committed the transaction. And I said to them, look, do you have problems where, at the end of the month when you do a reconciliation, things don't add up? And they went, yes. We have to run all of these SQL scripts to make sure that all the, the balances in the account's correct. So what happened was somebody had made a fundamental error 15 years ago, and the application did approximately the correct result. It didn't deliver the actual correct result. The next point is that the application should perform adequately. If you're going into the NoSQL space, you're doing it for a reason. You're probably doing it because you want to get better performance or better scalability. So the tool you choose, the technology you choose, the code you write, and the data model you use has to be all working towards that goal of performance. And the last point is that the code and the data model and the database has to be maintainable by the average guy or girl, which means they must comprehend what you have done, that you haven't done something so very clever and so obscure that no one else can maintain it. In my career, I've had the worst war stories in going back and looking at code and finding what on earth was going on there. And it was a particular design philosophy or a development dogma or a naming convention or a pattern that was fashionable at the time. But your code should be maintainable by the average guy or girl today in your team and in 10 years' time when the application is still in use. Okay, so I've spoken to you about why you shouldn't be frightened of NoSQL. Some things to consider at a very high level, mention some technologies. If you're interested in Aerospike specifically, like I said, I work for Aerospike, so I'm biased, and I do think it's got some amazingly cool technology inside of it. Jump on our website and go and see how much money you can save by using Aerospike. Once you've worked that out, you might want to try our Quick Start program where you can jump on and do something very quickly. And of course, if you have any questions, you can always ask us. So Yasmina, let's have some questions from the delegates.
Perfect, and we have many questions that have come in. So folks, you heard Peter, we're at the Q&A portion. Please open that group chat widget, type in your questions, send them in, and we'll take as many as we have time for. All right, we'll take a couple that came in a little bit at the beginning. Neil would like to know if you can go back over the difference between KeyValue, key document stores.
Okay, Neil, they're almost the same thing. They're almost the same thing. So a KeyValue store is very much like a hash table or an associative array where you have some kind of key that points to a value. So in a KeyValue store, it's a big database that looks like a big hash table or a big associative array. Depending upon the technology you're using, the value may be just a single value, or in the case of Aerospike, it points to a record that can have multiple fields or columns. We call them bins, where you can store multiple values related to the key. So a document store stores a structured, it's a specialized kind of KeyValue store. It stores a structure like a document, and a document is usually in itself a tree. Sometimes they're a graph, but mostly they're a mathematical tree. So if you think of a document store pointing something like MongoDB, where you have a key that points to a JSON document, the document has structure, and technologies like Mongo and Couch have the ability for you to do additional things with that structure, like query it in a certain way. So it's a kind of a fine definition between the two. And once again, use the right one for the job. Make sure it meets all of your criteria. Make sure it meets your speed, your capacity, your scale, and the features that you're interested in. Don't fall in love with a feature if it's not going to be fast enough for you or big enough for you. Thank you. Yasmina.
Perfect. Next question from Raphael. Where do object databases stand compared to this new wave of NoSQL database? Do you have any thoughts on why object-oriented databases never became more than niche solutions and never became as popular as the new NoSQL solutions?
Okay, yes, I do have some points on that. So an object-oriented database, in the modern vernacular, we would think of them as graph databases. You start with some kind of root, and you can find your object, then navigate to the next object, and then navigate to a collection of objects where you can navigate around. It's like chasing pointers, what we used to call a network database. So they arrived sort of in the early 90s, and they were quite fashionable about the same time object-oriented programming arrived. Unfortunately, they didn't fit dogmatically in most organizations, and they had a set of limiting capabilities. And they were, by and large, mostly single servers, so they don't scale very well. What you can do in the modern world, you can do many of the same kind of principles that you would do with an object-oriented database with a key-value store if you're very talented, or a graph database if you're less talented. Same kind of philosophies are involved. The difference being is that the technology for the OODBMSs has not really followed the trend of parallelism or clustering that you see in the modern NoSQL databases. Yes, Mina.
Thank you. Another question here. In RDBMS, we used to create entity relation diagram using crowfoot modeling. Can the same be used with NoSQL? Is there any other modeling technique which is better for NoSQL databases?
That's an excellent question. So, entity relationship diagrams allow you to get a good handle on what you're going to do in the way one piece of data relates to another. In fact, I still use them today primarily because everybody understands them. Everybody's learnt them. It's a common language. If I go to China and I speak no Mandarin, I can draw an entity relationship diagram, and my colleague who speaks no English can understand immediately what I'm talking about. The difference being in the NoSQL space is that an entity does not equal a table, or in the case of Aerospike, a set. So an entity, two entities that are related to each other may actually be stored, say, in a document in the case of Mongo, or could be stored in a combination of lists and maps in the case of Aerospike in a single entity. So the modeling technique is quite valid. The way you implement it becomes a little more specific to the technology. In my examples today, I used JSON to show you the actual way it laid out. JSON is a popular way of describing data. Yes, Mina.
Thank you. Folks, great questions coming in. Please keep them coming. Just open that group chat widget, type it in, and send it in, and we'll take as many as we have time for. All right, Peter, next question is from Jason. Do you have any specific tips for overcoming institutional inertia and fear of making modifications to legacy RDBM systems to begin using NoSQL solutions?
Okay, so this is an organizational problem, and I've faced it many times in my career. When something new happens, everybody goes, no, that's not the way we do it here. Or, no, that's not the right way because my mother said it had to be this way. You see it in programming languages. In the early days of Java, there was more religion in Java than there was in all the other religions in the world. So it is a problem. The way you can do it, the only way you can do it, is to prove from a business sense that you're going to be able to do something you can't do now. So it gets down to money. While we're all technologists and we love the geeky things that we do, the reason we do them is that somebody's paying us. And the reason somebody is paying us is because they either want to make some money from it, or they want to, if it was, say, a government organization, improve the country. It's that kind of a reason. So what you have to do is take the problem you're currently facing, some kind of speed or scale or capacity problem or parallel processing problem that you can't solve today. It's taking 36 hours in the day instead of taking 24, and do it in a proof of concept with another technology. And then if you can prove that you can get the throughput or the capacity or the velocity that you need, you can translate that back to dollars. So eventually the person who's blocking you or who's opposing you, who feels threatened in your organization, will get a commandment from the boss, the guy or girl who holds the checkbooks. And tell them that we're going to try this. On the other way, of course, is, you can leave and go and work somewhere else, but I don't propose that. Yes, Mina?
Great, thank you so much. We have a question asking, what is a two-phase commit?
Okay. There's a wonderful textbook by C.J. Date, and if you've never read it, it's a great thing to cure your insomnia. It's about 4 inches thick, and if you ever go to war, you can use it for a chest protector. In that book by C.J. Date, it's a textbook that we all studied with, it just talks about the ability to commit reliably to 2 locations. So if I'm an application, the classic example is I want to take $10 out of one bank account and put $10 into another bank account. And I want to do that atomically so that I don't lose money and I don't create money. With two-phase commit, a coordinator, me being the application, I'd be the coordinator, I'd say to the one data source, I'm going to take $10 from you. Can you do that? And that data source says yes. And it sits there waiting. And I say to the second data source, I'm going to write or give you $10. Can you do that? And the second data source says yes. Those are the participants in the transaction. Me as the coordinator, once I get the yes come back from both of them, I instruct each of them to actually undertake the transaction, each of them to do the commit. And this is done in an atomic way so that we don't end up with money taken from an account and not deposited, or money not taken from the account and actually deposited. So it's a piece of science and technology that's been around for a very long period of time, and it's a protocol that's well defined. Yes, Mina?
Thank you. Patrick has a question. In Aerospike, there is a concept of a high water mark. Once you reach this high water mark, Aerospike will shed, evict, or expire data. Other than expansion of server resources, what are the best options for managing the data so only non-useful data is evicted?
Oh gosh, we could have a long discussion about this, but the first thing is size your cluster correctly. We have a reasonably good way of sizing an Aerospike cluster to accommodate all of the data that you want to store at any one period of time. You can actually move the high watermarks, and depending upon your use case, don't just do this randomly, but depending upon your use case, it may be valuable. Eviction of data is essentially early expiration. So if you set the time to live on your record correctly, you might find that there is no expiration. But the easiest way, size your data correctly. If you haven't worked out how to do this, we'd love to help you. And then if you're running out of space, start a new node. Aerospike will include it in the cluster, rebalance the cluster automatically, and you'll have additional capacity. Yes, Mina?
Thank you very much. We do have just a couple more questions here. We're almost at the top of the hour. Let's take one here that asks about, is it recommended to use NoSQL for enterprise-grade applications? Is enterprise accepting the NoSQL?
The answer to that question is a qualified yes and a definite yes. So the qualified yes is NoSQL solves a certain kind of problem. Just because you've got a hammer, not everything is a nail. And you can shave yourself with a knife, but you've got to be highly skilled. So getting back to those images that I presented, certain portions of your enterprise application now stepping out of the typical online transaction processing stuff, deposit money into a bank account, purchase something from a website, moves into other areas. And so in these new areas where you need to have decisions made quickly, things done at speed, or decisions made over a large volume of things at scale, or in parallel with each other, then you start to use portions of NoSQL in your system. So the other side of it, are enterprises doing this? Absolutely. Absolutely. There are large financial organizations which I'm sure all of you have heard of, or at least, and some of you have used, who are using Aerospike and NoSQL today. You all know what Netflix is. You all know what the Weather Channel is. You all know what PayPal is. You all know what eBay is. If you're from India, you know who Emobi is. You know who Snapdeal is. If you're in China, you know who Alibaba is. These large organizations all use NoSQL for a portion of what they're doing. So yes, they are being used in the enterprise. Yes, Mina.
Perfect. And with that, we are at the top of the hour. So Peter, we're going to say a very big thank you to you for spending your time with us today, for sharing all your knowledge and expertise, and for presenting an outstanding webcast for us.
Thank you very much. I do apologize for the audio problem.
Thank you. Folks, we do also want to say a big thank you to all of you that joined our webcast today and participated. We hope you benefited from it. And also thank you to those of you that got up early or stayed up late to attend the event, as we had people joining today from all over the world, so we greatly appreciate your time. And folks, as we close out, we do want to let you know that Aerospike is a high-performance NoSQL database that is unmatched in offering extreme speed at scale with high availability and remarkable economy for companies with real-time mission-critical applications. Customers choose Aerospike for its consistently high throughput, low latency, seamless scale-out, and lower TCO advantages. Visit aerospike.com to get started now, and check out their TCO calculator to see how much you can save with Aerospike. Thank you again, Aerospike, for sponsoring today's event. Also, folks, I did push out to you an email address. If you have any additional questions, please feel free, email info@aerospike.com, and somebody will get back to you quickly with a response. Folks, this will conclude our webcast today. Goodbye, everyone.